Here we start part C, Fibonacci Formula and linear recurrence relations. C.1, golden ratio. We just solved our problem number 12, calculate Fibonacci numbers, but we used the algorithmic way to do it. So we use a computer program to find the answer. So that's the first method. The second method, we need to derive math formula for it. That is much harder than the first method, but more important, more useful. Because if you have the formula, you can do a lot of things. You can study a lot of nice properties without writing any program. But if you do not have the formula, every time when you need to do something, you may need to write a program. So that is not very efficient. Okay? All right. So now let's look at the math formula, how to derive it. Yeah. All right. Before we do that, this formula has a very interesting property. So it is related to the golden ratio concept. Yeah, I think you heard of the golden ratio. This number, magic number. Yeah. Here I use this picture. So this picture gives us some nice property of golden ratio. First, when we start with the Fibonacci numbers. So here you can see the smallest square, the area is 1. All right, so here we do not use 0. Yeah, because 0 you cannot see, right? Yeah. So F1, 0, area is 1, so you skip it, right? Yeah, but F2 also 1. Okay, so you have another circle F2. Yeah, F3 2. All right, so you draw square F3 2. Yeah, F4 3. So then you draw square with area 3 and so on. Okay, so when you do this kind of arrangement of your squares, so you can see, so you get a rectangle like that. So you can keep doing like this. So you grow your rectangle size larger and larger. Yeah. After that, you can create a nice curve, a spiral shaped curve like this. Okay, see the spiral shaped curve. All right. So here, let me produce in this way. Yeah. We start from here. We use one vertex as the center and the side as the radius. So we draw quarter arc. Yeah, not very nice. Anyway, yeah. So let me just draw quarter arc. Yeah, another quarter arc like this, quarter arc like that, quarter arc like that. Okay, so you can get a, really nice spiral curve shape. Yeah. All right. And then the relationship. Yeah. So if you consider relationship between the ratio of two adjacent. Yeah. So if we want to consider the ratio between two adjacent square areas. So you can see later, you will see. Yeah. It is the limit, right? Because the ratio is a rational number. Yeah. This rational number keeps changing, right? Keeps changing every time the ratio is different. Yeah. Then finally there is a limit. Yeah. So you have the limit concept, right? The limit approaches to the golden ratio concept. So very nice relationship. Yeah. So let's look at the golden ratio. The original definition of the golden ratio, we use a line segment to define this number. So we can divide one line. At the beginning, we have one line segment. We divide it into two parts. Larger segment, smaller segment, A and B. Yeah. And then when we do the ratio A over B, we know it is greater than 1, right? Yeah. This should be some number greater than 1, A over B. Yeah. It equals the whole line segment, A plus B, over the larger subset segment. Okay? Yeah. That's also greater than 1. Yeah. So we have this equation. So we set up an equation. The question is, we want to see how much is the ratio A over B. How much is the ratio A over B? Yeah. Because for this whole equation, you can see there are two variables, A and B, two variables unknown. Okay? Yeah. One equation, you cannot find answers for two unknowns, right? But we can find answers for ratio A over B. Yeah. So first we simplify A plus B over A to get a 1 plus B over A. After this simplification, now we want to know what is the exact number of A over B. Yeah. So we use another variable, X, represent this ratio. Yeah. After we introduce this X variable, so you can see B over A is just the reciprocal of X, 1 over X. So now you convert the original two variable equation to one variable equation. X equals 1 plus 1 over X. You only have one variable, one equation. So you can find the value of this X. Okay. After we simplify this equation, just remove the denominator. Yeah. We get this X squared equals X plus 1 equation. Yeah. Next, we need to solve this equation. Okay. To solve this equation, we need to use some formula. Yeah. I think most of you know this formula, okay. The quadratic formula. Yeah. When we have a standard quadratic equation, yeah, in this form, standard, A not equal to 0. Otherwise, it won't be a quadratic equation. Yeah. When A not equal to 0, we can write the roots or solutions, two roots of this equation in this way, this formula. Yeah, very famous formula. Yeah. Now let us use this formula to find our current quadratic equation. Yeah. So you can see we can easily write it to this standard form. Standard ABC. So we have the value A equals 1, B negative 1, C negative 1. So you plug into your quadratic formula, so you can get X equals 1 plus minus, because there are two possible solutions. So the first time you use plus, second time you use minus. Two solutions. Yeah. All right. But the question is, when you use the minus, 1 minus square root of 5, square root of 5 is greater than 1, right? 2 point something. 2 point something. 1 minus a larger number, it is negative. So that means when you take the minus sign, you get a number less than 0. But the X, based on our definition, that's the ratio of the longer segment A over the shorter segment B that must be greater than 0. So based on this interpretation, the negative value root does not satisfy our condition. So we drop it. After we drop the negative root, we only have one solution left. So this x is the solution of our current equation, the positive solution. We just take the positive solution. All right. We can estimate its value approximately 1.618. It is not a rational number because you have a square root of 5. It's not a rational number. So we cannot use the decimal expression to write its value exactly. We don't need. But this number is very important. So we use a new symbol to represent this number, phi. The Greek letter phi to represent this special number. And people call it golden ratio. So this is the famous golden ratio number. All right, so after we derive this number, next we want to connect it to the Fibonacci formula. All right, the Fibonacci formula is magic. It's a magic formula because the first impression, it is very hard to connect the golden ratio number with the Fibonacci formula. How can you connect that? Right? Yes. So very, hard to understand. So, but from this, we can see the power of math. After we apply a lot of math calculation, we can connect them in a perfect way. All right. First, let me just give you the formula first. So here you can see the general Fibonacci f of n for any positive integer n. Positive, so even 0 is okay. Right? Even 0 is okay. For any non-negative integer n greater or equal to 0, and if you plug in this formula, you will get exact Fibonacci number corresponds to n. So that, that kind of very powerful expression. All right. Definitely, the phi, you need to use this expression. So here you can see the left-hand side, it is an integer. Any Fibonacci number is an integer. But right-hand side, when you look at that, and you cannot believe it could be an integer, right? Phi, it is an irrational number. We call it irrational number. Okay? Irrational number. Not rational, irrational number. Then you raise to nth power. Then you do reciprocal, divided by root 5. Suddenly it becomes an integer. Right? So it's unbelievable. But after long math calculation, so we will use 2 or 3 videos. After that, finally, we will see it is not just the correct, it is a perfect formula. All right. So first, how can this be an integer? So we don't try to prove it. to be integer first, yeah, because it is not that easy to prove it is an integer first, right? Yeah, so we don't try to do that. Yeah, we just want to prove this whole expression is the Fibonacci number. So that's the first thing. Yeah. Here we do 2 steps. Okay. So actually we have 2 steps we can do. Okay. Yeah. First, prove the formula, right? Because we have the explicit formula, right? Yeah. Prove the formula. We have a target. Okay. So now we know what is our goal, right? We just want to get to it. We just find a way to reach it. So that's the first way. Prove it. You know the result. Right? Guess and verify, right? We know the result. Then we verify it. The first method. Okay? The second method, we assume we do not know the result. Right? Because first, this kind of formula, nobody can guess it, right? There is no reason that anyone can guess this complicated formula. Nobody is that smart, right? Someone has to derive it. So our second method is we derive it. When we derive, we assume we do not know it. We have no information about this formula. We just derive it. We just find a special method to calculate the solution of the Fibonacci number. So these 2 methods. Okay, yeah. So we will use the remaining 3 videos to do these 2 methods. All right. Next, the question. How can you connect the Fibonacci number to the golden ratio? Yeah. Here we don't know. Yeah. We don't know. Yeah. Nobody knows it until at the end people find this formula. Then they realize there is this connection. Before that, nobody knows it. Okay? All right, so we finish this video. Next, starting from next video, let us verify it first. Prove it is correct. Then in our last video, we will derive that formula. All right, yeah.